In today's tutorial we will have a closer look at the hybridization of the tert-Butyl cation and the tert-Butyl anion. Well, we have learned somewhere that the tert-Butyl cation is sp2 hybridized, while the tert-Butyl anion, for instance the gas phase, is sp3 hybridized. Well, but why is this the case? Well, for the tert-Butyl cation, this has clearly a planar geometry. Out of steric reasons, the CH3 groups try to avoid each other, and here, with the planar geometry, the CH3 groups are in maximum distance to each other. On the other hand, for the tert-Butyl anion with sp3 hybridization, well, we have here an sp3 hybrid orbital, a negative charge, and with two electrons in here, they need some room, they occupy space, and with the negative charge here we have an electrostatic repulsion towards those CC, towards the electron density of the CC bonds, and therefore these bonds move away from this negative charge, and then we have an equilibrium moving away from that negative charge, but don't moving too close to each other from the steric repulsion between the CH3 groups. But we should ask the question, why is this sp2 hybridization for the tert-Butyl anion, well, not energetically favorable, since here the CH3 groups have the maximum distance, just like here within that cation. Well, where is the center of the overall negative charge? It's here, in the center. And here the negative charge is closer to the electron density of the CC bonds, but also closer to the electron density of the CH bonds. There is an electronic repulsion. In this case, this electronic repulsion makes the CC bonds and the CH bonds a little bit longer. That means it is, well, weakening these bonds, and weakening the bonds is not at all favorable. It's disenergetically disfavored. Well, so we have the sp3 hybridized situation. This is, of course, an reactive intermediate and the sp2 hybridized situation is a transition state. It's a transition state between those two sp3 hybridized situation, the carbon, just as it is also the case for ammonia, where the nitrogen can move between the plane of the three hydrogens. Here, that carbon will move through the plane of those three carbons, and then, well, this orbital lobe will be, the bigger orbital lobe will be on the other side, And this situation is just in between the transition state between the two reactive intermediates, either here on top this lobe or on the other side at the bottom. Thanks for listening.